Hello students, last class we have studied about corrosion, definition of corrosion, how the corrosion occurs and the two theories involved in them, and also we have studied the types of corrosion. So I just recall it, the types of corrosion is differential metal corrosion, differential aeration corrosion and stress corrosion. So in differential metal corrosion we have taken two different metals having two different electrode potentials, and these electrode potentials is in different form. Therefore, the one which is having lower electrode potential will undergo corrosion, whereas the one which is having higher electrode potential will remain inert. So we have to choose a material such a way that the materials are made up of same metals. So that is the differential metal corrosion. And in the case of differential aeration corrosion, whenever an article is exposed to atmosphere, the atmospheric oxygen is rich and that causes cathodic region, and the one sample which is below the soil, that is not exposed to oxygen, therefore it acts as anode. So the one which is immersed in the soil will become anodic region and undergoes corrosion. And in the case of stress corrosion, when we have a part of iron rod bent and the bent parts experience more stress, and that becomes anode and it undergoes corrosion. So at the summarizing that previous class, the anodic region undergoes corrosion and cathodic region remains inert. So the pass of current from anodic region to cathodic region causes this corrosion to happen. Now the way to control is, we have many methods, mainly 4 methods to control. So the topic of today's discussion is corrosion control. So the main intention of the corrosion control is to control the rate of reaction and as well as the movement of electron from anodic region to cathodic region, therefore inhibiting the corrosion reaction. If we stop the corrosion reaction, then the corrosion is inhibited. So we have several types of corrosion prevention methods. So first one, let us look at that. As we see in the slide, it is having 4 main types. Under that 4 main types, there are subdivisions. Let us go one by one. The first one is the protective coatings. Under protective coatings, there is inorganic coating. Under that inorganic coating, there is anodizing and as well as phosphating. And the second type under protective coating is organic coating, that is coating of paints. Then the third type under protective coating is metal coating. Under the metal coating, there are 2 types, anodic metal coating as well as cathodic metal coating. Now let us go to first second category, that is cathodic protection. In the cathodic protection, we have 2 subdivisions. Those are sacrificial anode method and impressed current method. And the third protection method is corrosion inhibitors. These are the substances added to inhibit the corrosion rate. So under that there are 2 types, those are anodic inhibitors and cathodic inhibitors. And the last part of the discussion is the anodic protection. Now let us go one by one. The first one is inorganic coating under protecting coating. So as I say inorganic, so we are going to coat inorganic materials on the surface of the material which has to be protected. So we take example here. So the metals like aluminium, titanium, magnesium, vanadium and zirconium are made as anode, and in the presence of chromic acid, sulfuric acid, oxalic acid or phosphoric acid, etc. So now what this happens? So if I want aluminium has to be protected, or say example it is a bucket or is aluminium rod or whichever which is made up of aluminium has to be protected, I will take this sample and dip in some of the acids like sulfuric acid and I will prompt them to happen the corrosion. The corrosion happens on the surface of this aluminium and a small layer of aluminium oxide is coated on the surface. So that is called anodizing. I am purposefully making this sample to be anode. So forming a thin layer, thus the process is called as anodizing. So let us have an example on that. As I said, you have to take the aluminium, degrease it, clean the surface, then specific example, if you take chromic acid, take 3 to 10% of chromic acid and you have to pass current of 40 volt and maintaining a temperature of 30 to 45 degrees Celsius, then a thin layer of aluminium oxide is obtained on the surface. Now as the thin layer is obtained on the surface, what happens is that metal is not exposed to environment, thus inhibiting the corrosion. So since the corrosion is a surface reaction, the surface is not exposed to the environment, that leading the inhibition of the corrosion. If you want a thicker layer, so that if you have more wear and tear, your sample experience more wear and tear in the daily life, then we need supposed to have a thicker layer of aluminum oxide. So the condition we can maintain is you can enhance the acidity by taking 10% of sulfuric acid and maintaining high voltage and current around 24 volt and 160 milliamperes. So we get 24 micro thickness of the coating. So more thicker it is, better it is for certain excessive usage of the aluminum processes. So here is a diagram which I can show you how the process is done. So aluminum foil is dipped in the acid and current is passed. A thin layer of aluminum oxide is coated on this particular metal foil. So this is an industrial image where a large tank of acid has been taken, and as you can see in the corner there is samples dipped into that, and a thin layer of aluminum is coated. That's why it's not that shiny, and we can see a very clear image from the slide. Here is the zoom view of this image. So the large tank of containing chromic acid and some additional along with the electrodes are taken as seen in the picture, and it is dipped into the tank and is allowed for some time, maintaining the temperature and the voltage. The anodizing happens and the thin layer of aluminum oxide is developed on the surface, and when it is removed you can see it is coated with aluminum oxide layer. Next is phosphating. As the name says, phosphating means we are coating a phosphate material on the surface of the metal. So how we are doing it? So here we are taking phosphoric acid, phosphate of zinc or manganese, and in the presence of oxidizing agent like NaNO3 and maintaining a pH around 1.8 to 3.2 and also temperature of 35 degrees Celsius, we get a thin porous layer of phosphate, and this phosphate will again not allow the surface to be exposed to environment, hence the corrosion is stopped. And this phosphate also has some advantage. Why? Because it acts as a very good adherent for the paints. So painting is a secondary process where it gives a decorative appeal. So the phosphate, if you have the base layer, then the adherence of this paint will be enhanced by this method, that is called phosphating method. So you can see one of the tanks where phosphating is done here. Next is organic coating. So organic coating means, as I say, organic means is nothing but a polymers which has to be coated on the metals in the form of some functional groups like OH and carboxylic acid, and that will adhere in the surface of the metal, and that increases the decorative appeal. So I am not going to talk much on this, as my topic is more of inorganic and controlling by processes. So we will go for next method, that is called metal coating. So as we go for next method, that is the third one, that is metal coating. Under metal coating, as I said, there are two types, that is anodic metal coating and cathodic metal coating. As the first one, let us go for that, that is anodic metal coating. It is also called as galvanization. So galvanization is nothing but is a process of coating of base metal iron on the surface of zinc. So now what happens here is we take a sample which has been protected and we coat a metal on that, so that this metal reacts first with the environment, hence the one which has to be safeguarded is not exposed to the environment. So the first layer becomes anode and the second layer becomes cathode. So the corrosion happens to the layer which has been coated, and the sample which is inside is always safe. So therefore the name is anodic metal coating. So we'll take this in the next class, and we'll take up the diagram with the example how this process will be done, and also we are going to discuss further that what are the other methods of prevention of corrosion, that is cathodic metal corrosion and sacrificial anodic method, etc. in the next class. Thank you.